Yeah, all right. Today's video, I'm just going to sort of continue with a bit of binomial distributions, to sort of pick up all the bits and pieces we didn't cover in the first video, like the mean and variance, but also sort of looking at some inverse sort of stuff, figuring out a few little tricky things to do with binomials. Okay, so firstly, the mean and variance. What's the expected value? What's the variance? What's the standard deviation, etc. So just looking at that box there. So if you have if x is a binomial distribution, x is a binomial random variable, then the expected value is just simply n times p. So just multiply those together. If you think, we'll do an example in a second. If you think about it, it just makes perfect sense. Of course, we're going to expect the probability just to be multiplied by how many times you do it. Yeah, it just makes sense. You'll see in a second why that's the case. The variance, which is sigma squared, standard deviation squared, is equal to n times the probability of success times by the probability of failure. So np 1 minus p. They're the formulas that we'll need to use only when you've got a binomial distribution. Let's have a look at a question. So, probability of me, that's me, successfully shooting a three-pointer is 0.2. Now, that's rubbish. I don't get 1/5 of the time I get a three-pointer in basketball. That's just not true. That's an embellishment. It's probably more like 0.02, to be honest. But let's just go with that for now, for today. So, and let x equal the number of successes in 50 attempts. So, I'm going to try to shoot a three-pointer 50 times. And I want to find out what the expected value is. Okay, so how many shots would I expect to get in? If I'm shooting 50 times and the probability of me getting one in is 1/5, hopefully you can see what this is going to be. So 1/5, I'm expecting to get 1/5 of my shots in. 1/5 of 50 is 10. So we're expecting to get 10. Yeah, that'd be what we expect to happen. And it is. So expected value is, I'll just scroll up so you can see that, is NP. N was 50 attempts. The probability of me getting in one, probability of success was P. So 0.2, that's 1/5. 50 times 1/5 is equal to 10. So we would expect to get 10 shots in. And so that's why, when I said this before, it's obvious. When you see a question about it, it's just obvious what it means. Okay. Variance is not so obvious, but we'll just follow the formula here for today. So that's NP 1 minus P. And so that's 50 times, so I'll just change it to fractions, probably easier, times by 1/5, and 1 minus p is 4/5. So just multiply all those things together, and so that's going to be 4, so it's going to be 200 on the top line, so that's 50 times 4, over 5 times 5, which is 25. 25 goes into that 8 times, and so we've got a variance of 8. Okay, if you went and found your standard deviation, the question didn't ask for it, but standard deviation here, sigma will be square root of 8, which is 2 root 2, and so that's 1.4. So that's about roughly 2.8. And what that means is that on average, the average distance between the mean and each value is 2.8. So it's sort of saying that, and so I'm just giving you sort of some precursors about where we're going with all this stuff, is that the average is that I get 10 shots in. This is x, the distribution of x, the successes, and sort of on average, it goes down 2.8 and up 2.8. So it's going to go 12.8 here and 7.2 down here, and on average, so that will be, so like, 68% of my, if I do this over and over again, shooting 50 shots, 68% of my attempts will be between 7.2 successes and 12.8 successes. Hope that makes sense. Just sort of giving you a bit of context about what variance means and what standard deviation means, because we're going to be coming into normal distribution soon. Next, the probability of being successful in a viral trick shot is 0.006. Okay, so you know what I'm thinking. You know those ones you see on YouTube all the time, like people doing amazing trick shots. How many times do they try them, etc., etc.? So the probability of doing it once is 0.06. How many times would I need to attempt this trick shot to guarantee a probability of at least 0.95 chance of landing the trick? Okay, so we want to think, if I'm 95% certain that I'm going to land the trick, how many times would I need to do that to achieve 95% certainty of landing the trick? Okay, So let's just write down a few things. The probability of success is 0.06. Okay. N here, because this is binomial, it's either success or fail. N is unknown. Okay. And that's actually what we need to find in this question. It's asking us N, the number of trials that we need to do. Okay. We also know, I'm just going to write a few things down here. We also know that the probability, what's it saying? It's saying the probability that how many times would I need to attempt the trick shot to guarantee probably at least once time. I need, so the x is, I haven't said what x is equal to. Let's say x is equal to the number of successes. Okay, you might have thought that's obvious, but I'll just write that down just to remind us. So the probability that x is greater or equal to 1, right? So that's the probability of at least getting the trick shot successful once. Okay, we want that probability. What does it say? We want the probability to be at least 0.95. In other words, that needs to be greater or equal to 0.95. We want the probability that we land the trick at least once to be at least 0.95. So that's what that makes sense. That's what that means. Okay, so let's have a look at this. We need to, so we've got these three pieces of information. We've got that, and we need to figure out n. Now, the problem with this, right, is that you go, well, could I go and find this out, right? And if you think about it, can we find out the probability that x is greater or equal to 1? So that would be the probability that x equals 1 plus the probability that x equals 2 plus the probability that x equals 3. And you could figure out all those things and keep going. But then you go, well, where do I finish? Well, we don't know. We don't know the n value that we want to get up to. And we also need the n value to be able to use our, our combination formula that we had for the binomial. Remember the combination nx, p, 1 minus p, etc., etc., if you don't remember what I mean. And so we need n to be able to calculate those things. So that's actually really tricky. So that's not going to work for us. And what we can do is use the complement of this event to be able to get rid of the n in there. And I'll show you what I mean right now. Okay, when I say get rid of the n, but simplify the problem somewhat. So let me just do some little work here. Okay, so this is equal to, so therefore the probability that x is greater or equal to 1, that thing there is the same thing, if you think about it, as 1 minus the probability. What's the complement of that? The complement of that whole thing there, x greater or equal to 1, is just probability that x equals 0, okay? So in other words, 1 minus the probability that you never get that trick shot landed. So that's the complement. The probability that you land at least one trick shot, the complement of that is you never landing the trick shot. So we're using the complement of that, and what you'll see is that that calculation is much easier to do than the one we had before. So 1 minus the probability x equals 0. So now we've got this. Let's have a look at it, and let's put in 1 minus. Now, using this up here, well, I wrote it down. Oh, sure, I wrote it down. So I deleted it. It was in red before, right? The probability that x equals 0 is equal to the combination. I'm going to use this notation here. Combination. I'm doing how many trials? N trials. And I want 0 of them to be successful. Probability of success is P. My probability of success is 0.06. How many successes do I want? I want 0 successes. And how many failures do I want? It's funny that I want failures. Is the 1 minus 0.06. That's 1 minus P. How many failures do I want? I want n fails. Okay? And so that there is that there. Okay? Hopefully you can sort of see that. I've just used the formula from the last video, and that's greater or equal to 0.95. All right? Yeah. You could go stick this in your calculator, but let's just have a look at this in case you have to do it by hand. 0.06 to the power 0, that's 1. All right, so that just disappears. N0, let's just have a think about what N0, this is combination N0, so that's N factorial over N minus 0 factorial, 0 factorial. Okay, so that's what that's equal to. That's equal to N factorial over N factorial, 1 over 1. That whole thing is just equal to 1, so that also goes away. And so then you're left with 1 takeaway. 1 takeaway 0.06 is 0.94. to the power n, and that's greater or equal to 0.95. All right, so then we go to our trusty calculator, and we'll solve. 1, take away, I've already forgotten the numbers. Gee, my memory is shocking. 9, 4 to the power of n. I'll double check it before I hit enter. We want that to be, I need to check, is that right? 0.94 to the power n, and we want that to be greater or equal to 0.95. Yep, that's right, greater or equal to 0.95. We want to solve that for n. Okay, and I just want to double check that I've got that right. 0.95, 1 minus 0.94 to the power n. Good. Oh, whoops, I have... did I make a mistake? No. Oh yeah, I've missed a 0. Crap. Guys, just give me a second. I'll go back and fix my poor thing. I thought something looked wrong because I felt that probability looked too high. I've missed here. Sorry, my mistake here. I've missed a 0 there. Okay, sorry, I'm just going to add that in now. That's 0.06. I'll put everything in red that needs to change. So it's actually not that bad, right? Because it's 0.06 there, but that's to the power 0. But that 0.06 needs to go in there. And so that is not right here. So I'll cross that out so everyone can see my bad mistake there. Copying error. So that's going to be 1 minus 0.006 is 0.994 to the power n. That is greater or equal to 0.95. Sorry about that. You're probably screaming at the video, what are you doing, idiot? So going back to this now, it's going to be 0.994. 0.994 to the power of that. You get to see the difference in there. There you go. It just jacks up that how many times I need to do it. So it tells me that n is greater than 497.78. Remember, n is the number of trials, so n is a whole number. So we'll round up because we want the probability to be increasing. So that's going to be 498 is my answer. So therefore, using CAS, n is equal to 498 trials. So what that means is that so that I need to be sure that I'll nail at least one of those trick shots with 95% certainty, I'll need to do 498 times. I need to do that trick shot. And I reckon on YouTube, that's about how many times they do. Just before I go, I just want to quickly show you this on CAS. Okay, if you want to do this entire question on CAS, let's say that you get up to, so I'm going to scribble, going from there, right? I'm just going to take it from there. You've got 1 minus the probability that x equals 0 greater or equal to 0.95. Let's say you got up to here and you wanted to use CAS here. And if I rearrange this, I'm going to move that -1 over to this side. So probability x equals 0. I'm going to subtract 1 from both sides. So -0.05. And then get rid of that negative. So probability x equals 0. Divide both sides. So I change the sign. So it's less than or equal to 0.05. And so if I do that right, and I want to know what n is equal to, where the probability of x equals 0 is less than or equal to that. How many trials do I need to get that as a probability? Then what we can do is we can go to our CAS calculator and go menu, probability, distributions. We can go down to binomial. And here we've got these two inverse binomials. And what these two do, the first one will tell you for what accumulation of x do you need to have to get a certain distribution. And the second one, see how it says inverse binomial n, that tells you how many trials will you need to do to get a certain distribution. So we want to do this one here, right? So you see how it says number of trials, and this solves for you how many trials that you need to do to get a certain probability. So here we want the cumulative probability to be 0.05 because our question said, going back to it, find it. We want the probability distribution 0.05. We want it to be less than that. Okay, so 0.05, and then we want our probability x equals 0. Okay, so looking at this, probability of success was, don't get this wrong this time, Greg, 0.00. See, I forget already. 0.006. Yep, that's right. 0.006 probability of success. And how many successes do we want? We want 0 successes. Okay, so we want to solve that probability x equals 0 that, and we click on OK, and it tells us that to be able to achieve that particular thing, the number of trials that you need to do to achieve that is 498, which matches what we said before. So that's a calculator function that does the opposite of doing binomial. It's telling you the number of trials that you need to get a particular x equals something or other. Hope that all makes sense. There are a few more of the tricky functions of the CAS, but one that are well worth knowing to be able to get some of the harder questions in methods. I'll see you in the next video.